Lesson 2.1, parallel lines. I'm sure you guys have used parallel lines before, but we're going to go into them a little bit more in depth. So first of all, here's a manipulative that helps you see these lines are parallel and look at those angles. So look at the relationships. What relationships among the measures of the angles do you see? What do you notice? Like with angle 1, compare angle 1 with other angles, even as you manipulate. What do you notice? And hopefully you recognize a few things that are happening, or angle 2, 3, just kind of look with it, look at the manipulative, manipulate it, and then answer those questions. And these lines are parallel. Okay, identifying angle pairs. There are some vocab that you have to know. So it says identify the pair of angles for each of the angle types. So you have to know the types. First of all, let me show you this. There are 3 different types that they're pointing out to you right now. Corresponding angles. So if I look at these parallel lines right here going across horizontally, corresponding angles are located in the same spot but on the other line. So for example, look at angle 5. See how it's on the top of the parallel line on the left of that diagonal line? That diagonal line is called the transversal. So this is on the top left. Look at this bottom parallel line. What angle is at the top left? It's angle 1. So angle 1 is on top of the line to the left of the transversal. Angle 5 is on top of the line to the left of the transversal. Those are corresponding angles. So no matter which set of angles you are, there's a corresponding part. So look at angle 6. Angle 6, below the line, left, corresponds with 2. Below the line, left. 3 corresponds with 7, and hopefully you can see 4 corresponds with 8. And so if I clicked on that, those are the answers you're going to see. Okay. Alternate exterior. I want you to think of alternate as like opposite, like diagonal kitty corner. So opposite exterior means outside the line. So not inside, but like on the outside of the parallel lines. So if I said 5, see how it's on the outside? The opposite or alternate would be 3, because 3 and 5 are exterior and they're alternate. So alternate exterior angles. Can you see another pair? If I said angle 8, hopefully you know it's angle 2. Those are alternate exterior, and you can click on that and see the pairs as well. Alternate interior. So still alternate is opposite, kind of kitty corner diagonal, but they're inside those lines, inside the parallel lines. So if I said 6, opposite side of the transversal, 4 is the alternate interior, and angle 1 matches up with 7. So these are things you may have learned in middle school, you might not have, so we're just reviewing, going over it, make sure you understand. And they color-coded these as you click on them. So as I click, see 3 and 5 are the same color, 2 and 8, etc. Okay. Oh, let's go to here. Which angle pairs include the named angles? So angle 4, basically what you're going to do is angle 4. See if you can find the corresponding angle. Write it down. See if you can find an alternate interior. Write it down. Basically, those 3 vocabs that we just went over, see if you can match them. Now, angle 4 is not an alternate exterior because it's not on the exterior, on the outside of the parallel. So any of the vocab we just learned, you're just trying to find the matches. So you state the vocab and then state the angle that you see that's the match for both of these. Same side interior. This is a new vocab, new set of angles. So the same side, they're on the same side of that transversal, and they're on the inside of the parallel line. So it kind of makes this capital C. And what I tell students is same side makes a C, and they're supplementary. That's a whole lot of S sounds, even though makes a C, it starts with a C. But same side interior are supplementary, and they make kind of like this capital C, or backwards capital C, this way. Okay, so look at these. Supplementary means they add up to 180. 120 and 60 add up to 180. But if these lines are parallel and I move this, those numbers still add up to 180. still 180 no matter how I move it. So these same side interior that make that capital C are supplementary. No matter how the parallel lines move, they're still parallel, then that will be true. Those two angles add up to 180, which means supplementary. Okay. How can you express each of the numbered angles in terms of x? So using the vocab we just went over, if this is x, what other angles should also equal x? Hopefully you remember vertical angles. If you learned those vertical angles, think, okay, where's my vertical angle to angle x? That should be 7. So if x is here, angle 7, the measurement of angle 7 is x degrees. Okay, now think of corresponding angles. 7 corresponds with 3. So if 7 is x, 3 would be x. And then they're vertical angles again, so those would be x. But now also look at here, x and angle 6. Those make up a straight line. They're a linear pair. So the angle, there's one side is x and one side is angle 6. So together, x plus 6, angle 6, measure of angle 6, should equal 180 because linear pairs add up to 180. Okay, so you're just going to write all those different relationships. They have the solutions in here. They're kind of extensive. See, 180 minus x would give you the missing angles. Okay, so hopefully you can identify the angles and determine, are they equal to x or are they supplementary with x? Like 180 minus x equals that number or that angle measure. And here's an exact example. Measure of angle 4 is equal to 118. So find angle 4. If this is 118, what would all the other angles equal? Okay, use vertical angles, use alternate interior, same side interior, alternate exterior, corresponding, use all those to try to solve for all the other angles. And if you know those lines are parallel, then all of those measurements you should be able to find. And we are told because of these, because we're dealing with parallel lines, these are considered parallel because these little symbols right here, those double arrowheads or matching arrowheads, tell us that those are parallel lines. Okay, alternate interior. We haven't talked about them, but here they are. We talked about them just tiny. Alternate interior, they're on the inside and they're alternate or opposite from each other. So notice they are congruent or equal. If I move, let me see if I can move this. If I move these, see how no matter where I move them, they're still equal measures or still congruent angles. Okay, even if the parallel lines changed, the angles themselves are still equal or congruent angles or equal in measure. Corresponding angles also have the same properties. Corresponding angles, no matter how we move them, are going to be congruent if the lines are parallel. Those lines have to be parallel. So if a transversal intersects two parallel lines, so that's critical. They have to be parallel, then those angles will be congruent or equal in measure. If they're not parallel, that is not true. Alternate exterior, similar rules. So same thing, if the lines are parallel, see those arrowheads? Then the alternate exterior on the outside, they will also be congruent. And you can mess with these. These are kind of fun because you can mess with them and manipulate those tools on this. Okay, writing proofs. Now we're still new at writing proofs, so I don't want you to think that you have to go from learning proofs just in the last couple days to I'm writing a proof and I'm amazing at it. So be patient with yourself. First of all, set up a proof always with what is how you start a proof. So make that T-chart, assuming you're making a 2-column proof. So have the statements and the reasons on there. And the statements should start with what's given. So I'm going to start my proof right here with this M, those 2 lines, N. So if you didn't know this already, those 2 lines mean parallel. They actually look like parallel lines. So M is parallel to N. That is given. Okay, and then our proof should end with this. So I'm going to click the solution. Notice it's a drop down, so I can pull it down and see it, but I want you to know that every proof, start with what's given and end with what you're trying to prove. And remember, prove is not a rule. Okay, so let's see if they did that. They started with what is given. I'm going to try to see if we can see this picture. So these lines are parallel. I am trying to prove that angle 1 is congruent to 2. 1 and 2. Now, if you think about it, I just told you that rule. I just told you angle 1 and 2 are congruent because they're alternate interior. But if I am trying to prove alternate interior, I cannot use the rule alternate interior angles or the alternate interior angle theorem. So that's off the table. I have to figure this out a totally different way without saying, well, they're alternate interior angles. They're congruent. I can't use that rule because that's what I'm proving. So with the given, what else should you know? If the lines are parallel, you probably have to use some of the parallel rules. So I can't use alternate interior because that's what I'm proving. I could use alternate exterior. I could use corresponding. I could use same side interior, those rules. And if you're not sure what those are, go back and try to review them or practice them. And then I can also use vertical angles. I can use angles on a line or linear pairs. There's lots of rules you can use. So your proof might be different than this proof because every proof could be different as long as you get to the ending result. So let's just see what they did. They used same side interior. So hopefully you remember the review those rules we just went over. Same side supplementary. So that means they add up to 180. So angle 1 and 3 are supplementary. The next step, hey, look, the actual measures add up to 180. So first you state their same side interior. Then you state, well, what does that mean? Same side interior? It means they add up to 180. So definition of supplementary. And looking at this picture, what else adds up to 180? I know that these add up to 180. This is a straight line. Let's see if they use that as the next step. Yep, 2 and 3. Angle 2 and 3 together add up to 180. They used angle addition postulate, which is totally fine. You could say the rule is linear pair. You could even say angles on a line. So there's lots of different ways to say that two angles added up together should equal the total of 180 if they're on a line. So that's great. But if you look at step 3 and 4, you have something equal to 180 and something else equal to 180. So if two things are equal to the same thing, these are equal. So let's just take out the middleman and let's set these two equal to each other. So I think that's what they did. Yep. Angles 1 and 3, here they are, equal 2 and 3. Here it is. So they took out that 180. They both equal 180, so they set them equal to each other. And they said that's the transitive property. That's what that property is. If something equals this and something else equals this, they equal each other. That is the transitive property. Okay, so we know the transitive property. And we've done this before in a different video, but see how they have measure of angle 3 on both sides? They have the same thing on both sides of the equation. You can get rid of that. So how do you get rid of that? In this case, you would have to subtract. You'd have to subtract the measurement of angle 3 on both sides. When you subtract on both sides of the equation, there's a name. Subtraction, property of equality. So they subtracted the measurement of 3, and you're left with this. And if you look back here, what we're trying to prove, that is really close. But this says measure. That little m means the measure of the angles are equal, but I need congruent. So then you ask yourself, well, how do I get from equal to congruent? Well, what does equal and congruent mean? The definition of congruence means the measures are equal. So you can jump from the measures to congruence, or if you needed to, you could have congruent and move to measures are equal just by the definition of congruence. Okay, so hopefully that helps there. There is another example, and they're going to ask you to actually do it yourself. And you can add as many rows as you need. Start with what's given, end with what you're trying to prove, and do not use the rule you're trying to prove. So angle 1 and 2, hopefully you remember those are called corresponding angles. You can't use the corresponding angle theorem because that's what we're proving. So you might have to use same side interior. You could use angles on a line. Those make a line or supplementary. Or you could say linear pair. And then you try to get to the angle 1 is congruent to angle 2. And the previous example really helps. So if you didn't understand this, go over it again or watch the video again. Okay, this one's a little bit more complicated. So I would leave this for anyone that needs a challenge. It actually has the same features as the previous problems, but it just is more involved. So there's more given. So I'm going to, here, see how I can drop it down? So you can write each of these givens. You can write it all in one step, or you can do it in 3 separate steps. I think the book does it all in one. Okay, they do most of it, and then they'll do another one given later on. So start here. If a problem tells you lines are parallel, guarantee you're going to use one of the rules. Alternate interior, same side interior, corresponding, alternate exterior. Otherwise, they wouldn't have told you that the lines are parallel, because those rules only work if the lines are parallel. So as soon as you see that the given says parallel, think about corresponding, alternate interior, same side interior, alternate exterior. Okay? And then it has this symbol, which means perpendicular. If you're not sure what perpendicular means, you might want to look that up, but I will tell you, it means that they create a right angle or at 90 degrees. So just by knowing the symbols, it should lead you into some rules. I don't want to show you the rest, but try to do this. This is a challenging problem, but it's doable. I know you can do it if you put your mind to it, but make sure to do those other proofs first, because I would not jump straight to this proof. And again, there's more, trying it totally on your own. Again, if you are advanced, you really get these proofs, then I think you can do this. But if you're struggling at all, this might be a big jump up, and you might want to hold off on this for now. But you'll get there. All right, this one, finding angle measures. Here's some actual things that you need to do. What should the measure of angle 1? That means they're looking for an actual number. If you have the measure of something, they need a number. So look at these, and they are telling you AC is parallel to EG. So those 2 lines are parallel. On paper and pencil, I would actually draw the lines longer, the parallel lines, so that you can see them better and you can see them cut by the transversal. So 68, if angle A right here was 68, I wonder what angle 2 would be. There's a name for those. Hopefully you can figure that out. Okay, that's all the hint I'm going to give you for now. Okay, same idea. Look, it's very similar to the barn problem, 68. Actually, is it exactly the same? Nope, this one has this 56 as well. So similar problem. And again, if you want to extend those parallel lines, go right ahead. All right, here's all the theorems all at once, so they're all in one spot. So there are 4 special angle relationships when the lines are parallel. These are only true when the lines are parallel. So same side interior, alternate interior, corresponding, and alternate exterior. These rules need to be memorized. Not all rules have to be, but these are those 4 rules. They'll just keep coming all year long. So these rules, definitely understand. You don't have to know what the saying is word for word, and you don't need to memorize angle 1 and 2, but you do need to understand the concepts. So if lines are parallel, then same side interior, add up to 180. If lines are parallel, then alternate interior angles will be congruent. If lines are corresponding, or sorry, I said that wrong. If lines are parallel, then corresponding angles will be congruent. And if lines are parallel, alternate exterior angles will be congruent. Make sure you understand these rules. They're not going away. You'll know them hopefully back and forth soon, because they're going to keep coming back. And then you're going to have to ask some questions and do some practice problems. At this point, hopefully, anything that you're not understanding, you're going to go back to the beginning of the video and watch each of those rules and examples.